Everyone, we're going to do some complex numbers questions again, and this is taken from the Raffles Institution 2019 Prelims Paper, Part 7b. So if you're ready, let's jump right in. Now the question wants us to find the possible values of w in terms of a only, given that w square over w star is a real number. So what we can do is to express w square over w star in terms of a and b. So w square over w star is equals to a plus b I whole thing square over a minus b I. Now to remove I from the denominator, we are going to multiply by the complex conjugate a plus bi on the bottom and top of the fraction. So this will give us a plus bi whole thing cube over a square plus b square. Simplifying by using your binomial expansion, we will have a cube plus 3 a square bi minus 3ab square minus b cube I over a square plus b square. Now let's try to group all the real part of the complex number together and the imaginary part of the complex number on one side. So this will give us a cube minus 3ab square plus 3a square b minus b cube I over a square plus b square. Now you realize in the question that w square over w star is purely a real number. This implies that the imaginary part of this complex number is equals to 0. So extracting out these terms from the fraction, we will have 3a square b minus b cube over a square plus b square is equals to 0. This would mean that 3a square b minus b cube is equals to 0, and by factorizing out b, we will have b open bracket 3a square minus b square close the bracket equals to 0. Now it is here that we can see that b is equals to 0 or b is equals to plus minus a square root 3. And don't forget to reject b equals to 0 because the complex number wouldn't exist. Substituting b into w, we will have w equals to a plus a square root 3i, or w is equals to a minus a square root 3i. Don't forget to answer to the requirements of the question. So let's try to approach b part 2 of this question. You realize in the question that a is a positive number. This means that if we illustrate the complex number on the Argand diagram, this complex number will lie on the first and fourth quadrant. So let's consider w equals to a plus a square root 3i. The argument of this complex number will be tangent inverse, open a bracket, a square root 3 over a close a bracket, and if we simplify it, we will have tangent inverse square root 3 over 1. This means that the basic angle is equals to pi over 3. This means that the argument of w is equals to pi over 3, and not forgetting w is also a minus a square root 3i, and this means that the argument of w can also be minus pi over 3, which is simply a reflection of the argument in the first part. So I do hope you learned something from this video, and I'll see you in the next.